these truths to be self-evident.
That all men are created equal.
As a member of Congress, I get to have a lot of really interesting people in the office. Experts on what they're talking about.
This is the podcast
for insights into the issues.
China, bioterrorism, Medicare for all. In-depth discussions.
Breaking it down into simple terms. We hold
these truths. We hold these truths.
With Dan Crenshaw.
The Eagle has landed.
Welcome back, everybody. Best podcast ever. Give us 5 stars, please. Today we're going to talk about hurricanes and weather because especially if you're one of my Texas constituents, you know, we have a lot of weather, and this has been described as potentially one of the worst hurricane seasons, at least relatively worse than past seasons. And we've already had some weather, to say the least, in the Houston area, some flooding, some crazy windstorms. And so people are probably curious what's in store for the future. So today we have Dan Reilly. He's a lead meteorologist from the National Weather Service, joining me to tell us how do they predict tropical storms, hurricanes, and coordinate with other agencies to actually prepare for these kind of disasters. Again, this is a huge topic in Houston ever since 2017 Hurricane Harvey, the second costliest hurricane in U.S. history, just behind Hurricane Katrina. 68 people dead, estimated $125 billion worth of damage. Just this month, we had Hurricane Beryl hit Houston, mostly a windstorm, but power outages that I think are still continuing in some areas. Almost $5 billion in economic damage for the state. So these are the things we got to take seriously. They're part of life, and preparation is key. And part of preparation is understanding how to predict them. So, Dan, maybe if you could just give us a little bit more background on what the National Weather Service actually is. In your role as a warning coordination meteorologist, you're specifically here for the greater Houston region.
That's right, Congressman. The National Weather Service, our role is very clear. Forecasts and warnings for the protection of life and property. We work closely with the jurisdictions, with the state, local, and federal agencies, trying to give them the weather information they need to make decisions to protect the public. And of course, a lot of our information goes straight to the public. We also work closely with the local broadcasters to try to all get on the same page. So my role as the warning coordinator is to work with those core partners, sort of a liaison from our office to make sure we're doing the right job for them, giving them the information they need in a format that works for them. So, I attend a lot of the emergency management meetings, talk with elected officials like yourself and staffers and such. And that is my role as the warning coordinator.
Who owns all the equipment? So National Weather Service, I mean, so there's sensors, there's equipment, there's radars. I mean, I don't know. I'm just talking out of my ass right now. But there's stuff that's needed to predict weather. Who owns, is that like not, but everybody uses it. I mean, the news services use it. Does everybody have their own stuff? Do universities have their own weather balloons? Do you guys own most of it? How does this generally work? It's sort of a civics 101 question.
Yeah, great question. As far as the National Weather Service, the government owns the satellites, the radars, really the taxpayer owns these. All the information is available to everyone, as we are a government agency. And there are
when local news weatherman is looking at he's saying this is going to happen and blah blah blah. Like they don't have their own sensors out there. They're pulling from the National Weather Service and then they're reporting it.
Mostly, Congressman. Some of the stations do have some local radars, but mostly they're showing our information. We actually, not everyone may know this, we actually have an open chat room with the broadcasters. So there is some coordination, even with the television folks going on behind the scenes. Our goal is to all be on the same page, and we recognize a lot of people get their weather information from TV news. So,
of course.
Yep.
And again, Civics 101, your agency, it's National Weather Service. It's part of NOAA, National Oceanic and Atmospheric Administration. What else does NOAA do? Because they fall under the Department of Commerce, so it's this whole thing. What else do? They do a lot of research, obviously. What else?
Right. Yeah. We're kind of the atmosphere weather part of NOAA. There's the big ocean presence. There's the National Ocean Service. There are people that operate the satellites. We actually work with NASA on some of the satellite aspects. We have even space weather. We have a climate prediction center. So a lot of different aspects of the
Yeah.
atmosphere and the ocean.
Yeah. I think that well, eventually we'll get into the climate prediction because that's always a hot topic. And for good reason, it matters because, you change a couple variables and you've got costs that are widely different, which means policymakers have to make wildly different decisions. It's a constant debate. But on this season, so the 2024 Atlantic hurricane season is going to be intense, according to y'all. Maybe 4 to 7 major hurricanes. Well, why is that? I mean, what are the factors that we face that are different than last year? So last year wasn't that bad.
Yeah, last year we had what's called an El Nino, and that tends to be a limiting factor on the number of storms. We had warm water last year, but an El Nino this year it's switched over to something called La Nina, and that taken on its own leads itself to more storms. Plus, we have record warmth in the ocean waters themselves. Higher than they've ever been. Our June waters were more like August. And so put those two things together, and that's why these seasonal forecasts, the numbers have been so high. Knowing NOAA going for 17 to 25 named storms, that includes hurricanes and tropical storms. And
But can you explain the difference between an El Nino and La Nina? What does this mean?
absolutely, and it's not intuitive. It's based on fundamentally the ocean water in the Eastern Pacific near the equator. And
Okay.
it turns out when that water is cold, you may be thinking, why does that affect hurricanes in the Atlantic? But it actually sets up air currents and air patterns in the atmosphere that correlate with less shear where the storms form, less things that can prevent the storms from forming. So uh, that water anomaly in the Eastern Pacific actually has impacts all across the globe.
So wait, but that's El Nino. So El Nino means it's colder in the Pacific.
Let me back up. I may have misstated that. The El Nino is a tongue of warm water
Okay.
in the Eastern Pacific near the equator. La Nina is just the opposite of that. And so last year we had that warm El Nino. It tended to inhibit the formation of hurricanes. This year, though, we switched over to a La Nina. The cycle switches probably on average every 4 years, but it's very irregular. We might
Hmm.
go 8 years without a La Nina, for example.
We have no idea what causes like a random warm or cold current in the Pacific.
Yeah, I mean, that's a great question. It's actually a coupling of the ocean and the atmosphere. There's a trade wind component of it as well. The winds force anomalies on the ocean temperature, and it works the opposite way. Warm ocean water leads to more thunderstorms, which leads to impacts on the air. So technically, it's a coupling of the atmosphere and ocean. It's just something that's been observed for many, many years.
Yeah, and it is counterintuitive because so there's a warm ocean current near the equator in the Eastern Pacific. We certainly didn't feel that ever in San Diego training for seal training because it's always cold in the water. Uh, I'm sure a lot of SEAL trainees will be happy to hear that water is getting warmer. There's a lot of hypothermia going on over there, which is
Yep.
good. It makes you tough, but that's the so. But that inhibits hurricanes in the Atlantic region. Okay,
Yeah, think
so
of it like this.
why is that?
Think of it like a drum. If you beat a drum in one part of the drum, the whole drum resonates. You get oscillations all over the drum, and the atmosphere is a sphere of a globe around the globe, and so it actually has. If you force it in one part of the atmosphere, you actually get waves that emanate out of that area. So that's the best analogy I can give. You get forcing in one part of the atmosphere, and it impacts air currents all over the globe. And in this case, cold La Nina in the Eastern Pacific means more hurricanes in the Atlantic.
So even though there's colder water in the Pacific, and even though warmer water tends to create more hurricanes, it's not the warmer water is in the Atlantic. When you say there's warmer water this year, you mean the Caribbean, the Gulf of Mexico, the Atlantic.
Yeah, you can almost think of those separately. The warm water is in place in the Atlantic. And so we've got that in place. You couple that with the more favorable wind patterns that we get with La Nina, and that's why these forecasts are so high for a number of storms.
How soon do you know that a storm is brewing? What goes into tracking something, and what's our Maybe go over that.
Yeah, that's a great question. There's analysts at the National Hurricane Center, and they're studying satellite data every day, and they do an analysis on disturbances that are out there. There's thunderstorm clusters, typically, there's waves coming off Africa, and they'll circle and highlight ones they think could develop. And so the first indication might be to see a circled area with a hatched area and a probability assigned. And everyone can see that on Hurricanes.gov. I recommend checking out that website. It's right up front. It's called the Graphical Tropical Weather Outlook. Look at the 7-day version of that, and that'll give you your first indication there could be something developed. And the Hurricane Center continues to study those. Eventually, some of those will develop into depressions and storms. And then you'll see a whole host of initially model tracking on those. And then as they become depressions, you'll see the familiar forecast cone start to come out. Here at the Weather Service Houston office, we're also looking at all those things and briefing our local partners on, hey, heads up, there is something out there. We may have to swing into action soon.
Yeah, and companies like Centerpoint have that information too. They probably should have known. This is the big issue right now. Is that there's a lot of accusations that they should have known that it was coming this way. I think the Hurricane Beryl in particular changed directions, but we knew about it ahead of time, and it seems like companies like Entergy prepared a little bit better. So that's part of the investigation we'll be looking at. Actually, I want to go back a little bit. Why the names El Nino and La Niña? There's got to be an origin story there.
Yeah, no, El Nino actually refers to the Christ child, actually. It's because they noticed this water pattern fishermen did locally occurring around Christmas time. I believe that's the story. I hope I have that right. If not, someone listening to the podcast will straighten that out. But I believe that's the very start of it.
Because we're talking about equatorial Eastern Pacific waters, which is like Ecuador.
Right, exactly. Local fishermen.
That's another reason the origin is Spanish.
Exactly. And local fishermen, I believe, noticed this first. It affected their catches, things like that. So I believe that's the start of that.
What would it take to figure out why this happens and be able to predict this is going to be a La Nina year, this is going to be an El Nino year? Like, what more information would you need as a scientist to understand that better?
Yeah, great question, Congressman. The Climate Prediction Center, which is part of NOAA, actually, that's part of their task. There are models trying to predict that. And every month, they put out an El Nino, La Nina forecast, looking out the next several months. And, they have an array of climate models. You can see what each of them is predicting for the water temperatures in that zone. And, there's certain confidence levels, just like weather, it's not a certainty. But as you get closer and closer, you can get a better handle on that. So, that is an area of research too. They're always trying to improve those models and validate them. But there is an effort underway now in NOAA Climate Prediction Center. You can go to CPC, ENSO, and you'll see their El Nino forecast. Essentially, they even have something called an El Nino watch, or La Nina in this case.
Yeah, and then but of course it takes a few steps to then understand what that actually means for your daily life or the rest of your summer. Here's another random question to throw out there, because I think a lot of people don't understand this, is what does it mean when there's a 50% chance of rain? What does that actually mean?
Yeah, that's a great question. I've actually worked in forecast offices where the forecaster wouldn't use 50% because it sounds like you're flipping a coin almost. And what it actually means is the chance of rain at a point. So it could be a day where 50% of the area gets rain and 50% doesn't.
More of a geographical statement. Like you're going to get rain, but it's going to be like 30% of that area we're talking about.
Right. Most of the time, that's what that means. It's a probability looking out your window that you get rain, for your location, it may be 30, 40, 50%. So that's usually what it means. It's an aerial probability. Yeah.
Okay. And so 100% means everybody in that area is going to get rain. 10% mean, because it is confusing, because when you say chance of rain, it does imply a probability. Like we may get, there's which, because you may, some people look at that and they're like, okay, well, there's a 70% chance I won't get any rain, which I guess is
Yeah.
true. So but it's
Yeah. I want to be
more
careful
complicated.
that it is complicated. It is confusing. Technically, it's a point probability looking at your window, but it's not always an aerial probability. It could be looking 5 days out. Maybe there's 30% chance everyone gets rain. You follow me? So, it can be an aerial coverage thing, like around here, it's quite often, maybe 30% of the area gets a thunderstorm, the rest doesn't.
Right.
And so you'll hear that 30% chance of afternoon thunderstorms.
Because
So
it's based off of like a single point. So if we say Houston has a 30% chance of rain, Houston's a large area. And so like where is that one point that's definitely going to get rain? I mean, you got to usually know at least there's one point that's going to get rain, but where's that?
yeah,
Like for Houstonians in particular, like where is that actual location? So your
right.
office, like where is it?
Yeah, and that's something we're not good enough. We can't say where in Houston that storm is going to set up, at least not yet. So that's basically the takeaway is if you hear a 30% chance of rain for Houston, it means you're going to have some thunderstorms probably here and there. But it just depends where they pop.
Yeah, you never know. And then it could be 100 degrees and then thunderstorm and then beautiful sunny skies and then snow. Who knows?
Yeah.
And this gets into, more controversial topics about like just the climate predictions in general. I mean, it's very difficult to predict the weather 24 hours out. We have a decent idea, but it's not going to be exact. And that's 24 hours out. And that's with all the data and satellites, radars that we have. What I understand from NOAA, because I use this statistic often, is that when it looks at the broader climate predictions on hurricanes, that you see an increase in intensity of like 5%. I don't know if these are, I've been using these numbers for a couple of years. I don't know if they've changed. Increase in intensity over the next, 100 years of 5% intensity increase, but a 25% decrease in frequency. And the other citation I often see is that we really don't have evidence of a long-term increasing trend in hurricanes. And, that's also a function of the data we've had for the last few decades. I mean, it's fairly recent in terms of, atmospheric and geological long-term trends, right? So what's your take on that? How do we describe those climate predictions to people properly?
Well, Congressman, I'm not a climate expert, but my read of those science reports is kind of like you said. There's no clear signal as far as the frequency of hurricanes. There is some hint in recent years of perhaps more intense hurricanes, and let me give an illustration for that. And in the last 6 years, we've had 8 landfalling U.S. Cat 4 and Cat 5 hurricanes, most of those on the Gulf Coast. That's more than the previous 53 years. So it just seems now, from a scientific point of view, the scientists have to figure out, well, is that just an unusual period of time, or is that part of a trend? And so that is one thing. I think there's a sense probably that maybe more intense storms, but like you said, there's no hard science perhaps demonstrating that. The other thing I've seen in the reports is perhaps more storms with heavy rain. A warmer atmosphere has the ability to hold more water and produce higher rates. So we call this climate attribution, and it's really an active area of research. There's a lot that's not known. I think this is kind of what you hit at there. But there's no denying in recent years, we've had a number of these really intense landfalls, many of those intensifying rapidly over the Gulf. That's one of those things that, there's a lot of people wondering if that's a trend or if that's just an unusual period of time.
We just don't know. It is a constant point of debate, because there's, there's the idea, of course, that it's human caused, and that if you're pumping more CO2 into the air, there's a warming factor, and that warming factor leads to massive costs. But the question is, what kind of costs? And if you get those costs wrong, and you want to spend a ton of money trying to mitigate those costs now, but you don't really change the future, then you've made a poor choice from a policy perspective. And that's where I come in. I mean, this is the kind of conversations we have on our committee, especially all the time on energy and commerce, because we oversee environmental regulations and whatnot. And so trying to understand like what we know and what we don't know is a constant question I think we have. Maybe another thing that people don't know, shifting gears a little bit, is how do storms actually get their name? Where do these why Beryl? What a weird name.
Yeah. Yeah. I mean, it's interesting. Initially, storms started to be named in the Atlantic in 1953, and they were given women's names. Prior to that, they were numbered, 1933, number 1, 2, 3, and so on. And then more recently, we're alternating between male and female names.
Yeah.
These names get decided by an international body, part of the World Meteorological Organization. That U.S. is a part of that. And every year they meet to discuss names. Now, the names are all lined out for the next 6 years. And then in the 7th year, the names get repeated. So the ones we have this year will be repeated in 7 years, unless a storm has a huge impact, in which case its name is retired. And that same body of people, international body, decide which name should be retired and what name to replace it with. So, there's a lot of unusual names, on the list. Beryl being one. There are some names that have come back again and again. My name, Danny. I remember growing up in Virginia and hearing about Tropical Storm Danny. Well, that name keeps coming back, every 7 years. So eventually, when that name gets retired, maybe I'll retire as well. Who knows? But that's a little bit about the naming. And what's interesting, so I understand it even gets heated sometimes. Like there's really debates about whether we should retire a name or not. So I've never been in that room, but that's a little bit about how it works.
Yeah, I wonder if they try to choose names that are fairly uncommon, just to keep less people offended by a bad name.
Yeah, I mean, over the years that we've had Bob, and Bill, and those are, more common names. But yeah, there seems to be there's more unusual names now.
Yeah.
The most retired letter is I, by the way, and I can imagine it's hard to come up with new I names, but
Yeah,
that's the most retired letter.
To just make up some stuff. This is kind of an interesting topic, is the butterfly effect. And 1963, a scientist named Edward Lorenz, I'm not sure exactly what he discovered, but mathematically small changes can have large consequences in weather. And this sort of became known as the butterfly effect. This idea that the butterfly's wings, the flap of a butterfly's wings might ultimately cause a tornado. I mean, that seems like an exaggeration, but you tell me, how does that kind of thinking affect weather prediction over the years?
I was fortunate to meet Edward Lorenz at MIT, and it was interesting just to see him hanging around the department. Very interested in weather, but also a great mathematician. And what that really means is small changes in the current conditions can have a huge impact down the road. And so let's say we have a computer model that we don't have exactly initialized right. That small difference will have a huge impact on the weather, days out. And one implication of that is the weather models, there's really no skill, arguably beyond 7 to 10 days. So if people get online and they see a model forecast 14 days out, don't pay it any mind. Small changes will lead to big changes in the forecast. We even see that with a storm like Beryl. 10 days out, oh, it's going to be weak and going to Mexico. But wait, it just moved a few degrees to the north, and you can see that small changes early on bring it right up into Texas.
And how many of those factors are there? Is it even is it even possible to predict? And again, this gets into the longer term climate change debate, which is, these models have, I don't even know how many thousands of factors that can be subjectively changed. So how do we deal with that?
Well, I will say this, hurricane tracking models have improved so much because of increased computing power. And so it's not a lost cause, that having the better resolution, the better data feeding into them is going to give us better forecasts. But it does give us that theoretical weather limit, on the order of 10 days. Climate models, I think, are constructed a little differently. Um,
Yeah, yeah. I mean,
yeah,
to be fair, these are
yeah.
two totally different conversations. Hurricane modeling within 10 days, totally different than 100 years.
But it's a little, it's a fair question. What we're talking about is something called a nonlinear system. This is the type of system that, really expands out as far as possibilities, this whole butterfly effect. So, um, that's a little bit outside my expertise, but, climate modeling is a younger science and, as you said, very important to get it right.
What are some of the best practices people can take to prepare, whatever that preparation is for? Doesn't really matter what the National Weather Service is saying. People in Houston know that we're going to have weather. So, what do you tend to recommend? I've started looking into generators as a potential purchase option. What do you think? What would you recommend?
Well, I do want to point people to our website, Weather.gov /Houston. Also, our social media, NWS Houston. We have actually a preparedness guide with checklists and things of that nature. And we have it in English and Spanish. And we want people to go there let us be that trusted source of information. The same briefing we're giving the congressman and his staffers and the emergency managers, we're putting out there to the public. We want you all, there's so much information out there, especially social media, not a lot of it. There's a lot of bad information too that's kind of meant to scare you. And so we want you to stay informed and let us play that role for you. At least be one of your weather sources. As far as more concrete things, I think the generator is something I've considered as well. How can you not with the freeze we had, the hurricanes? But you want to build a kit. It's going to have water, non-perishable food items, medicines, cleaning supplies. Think about 1 gallon per person per day for 5 days. And that's a lot of water. But, when you're out of water, your AC's not running, that's got to keep you going, for 5 days. Keep that gas tank near full. I mean, we just went through Beryl. We got a taste of a Category 1 hurricane. And, you see all the inconveniences with power out, difficulty to get gasoline, long lines. Yeah, you want to be starting with a tank near full. Get your insurance checked up. We really recommend flood insurance because your homeowners doesn't cover floods. These are just a few things off the top of my head. But like I say, we do have that preparedness guide on our website. There's a whole lot more in there. Look it over, share it out with your friends and neighbors.
Uh, Um, Hurricane Beryl was only a Category 1, so the lowest category, but still caused quite a bit of damage. I mean, pretty high winds. So how does that categorization work? And I think some people might be thinking, how the heck was this categorized just a 1 with all this damage? How does that work?
Yeah, we really don't like the category for that reason. It's a scale of 1 to 5. So you think 1 is probably not that bad. But 1 is, winds on the order of 80, 90 miles per hour. That's enough to cause a lot of damage and definitely to take out power. We start to see power loss really with winds about 60. So even a strong tropical storm can have that impact. We recommend looking at the more detailed forecast. We're going to try to break out what are the waves going to be, what kind of impacts do we expect, where do we expect storm surge flooding. We haven't really talked about that. Those folks in storm surge zones, it's vitally important they get out and they need to know it's coming. So, we're in the weather service, we're going to try to get beyond that number and just break it down in plain language. What do these winds mean? What kind of impacts do we expect? How much rain? What kind of flooding from that rain? Harvey, Beryl, Ike, they're all completely different storms. And it's our job to let you know what to expect so you can make that right decision.
Yeah. And what would have made Beryl a Category 2? Just higher winds, more rainfall? How does that
Yeah,
categorization work?
the scale is strictly wind. In fact, the word wind to Congressman was added after Ike because people were getting confused by it. There were people at the coast who didn't leave because it was a 2, but we knew it had a surge, more like a 4. So they added the term wind to that number. It's just a wind scale around the center. It is really what it's telling you. Harvey was a tropical storm for us, but we saw the impacts it had with all that rain.
Hmm. Exactly. Well, that's helpful, and we'll make sure that people have those websites in the comment section underneath the podcast, so they can see that and make sure they're prepared. So, Dan, thanks for what you do, and thanks for being on.
You bet, Congressman. Thank you as well.